How's everybody doing today? Guess not too good. All right, just waiting for a couple of more people to take their seats. Okay, thank you guys so much for coming to our Hardware Massive. This is the second in our series. I'm just going to make the intro really, really short today. Thank you for coming to Hardware Massive at Future World Central. So really short intro about Hardware Massive. We are a global platform that connects people in the hardware ecosystem, not only globally, but locally as well. So we are the Taipei chapter. That's what we are here. So every month we get a special speaker to come and share his experiences on hardware. So before we start the main event, I would like to invite our co-host, Ellen from Triple, for some short words.
Okay, let's do it like a more relaxed way, because this is gonna be the least hard parts from today. So my name is Alan. I'm working on Triple for international partnership. Can I know who is kind of like stop or have intention to do kind of like innovation for hardware? Okay. So we also have Triple members who are Taiwan suppliers who can support hardware stuff. So if you see the name tag in front of them, then they are our members. Welcome to network with them and talk to them. Or if you are looking for specific supplier, can come to our PN, Triple PN Marco there. We have Jerry. Yeah, here, the one with this badge. You can come to us and we can refer you to the specific supplier to talk to your project. So let me quickly have 5 minutes to explain what do we do. In abbreviation, we are Taiwan Triple, called Taiwan Rapid Innovation Prototype League for Entrepreneurs. It's quite a long name. So, but if you see this logo, it's us. And what we do, we actually help hardware staff to connect with, not only connect their hardware partner, but also the resources in Taiwan. So we are actually the matchmaking platform, and this is actually government initiative from Ministry of Economic Affairs, and we are E3 under Industrial Technology Research Institute to execute this project. So this project has been 2 years. Almost 2 years for next month. Okay, so to start with the quote from Manu Kumar from K9 Venture saying, you can't spell hardware without the hard parts. So I'm going to start with this quote. And there's a statistic showing the crowdfunding failure rate. 75% of the project will be delivered late. And the larger the project, the longer it will be delayed. So it shows it's not easy. And there's a few possible reasons, like actually the start with a small team. So they actually, from the first place, they find the wrong manufacturers. So they are not a good match. They are small scale, but you're looking for like a large OEM, ODM. So it's easy to get your project, not to be supported. And or because the manufacturing process is unfamiliar with from the start, so they don't know those hidden costs behind it. Or even when they do the prototype, because prototype is not equal to manufacture, so the prototype probably will not be unproducible. And it's all about the scale differences. Usually start with the small teams, or they have few people, probably only focus on the software. So they don't have the skill to do full stack of engineer to support their hardware projects. That's why you need to find the good supplier who are actually your partner, and they are not your service provider. Because treat it as a partner. They are the one who control your cost, quality, and the schedule. So having the hope like your innovation or your product will be the next big things. And so what we suggest is to involve those hardware partners in early stage, so you get better visibility on your projects. You got next big quality product to be delivered in the market, and try to build a long-term relationship with your suppliers because they are your first customer. And in Triple, we connect the hardware staff to find different suppliers in different outsourcing partners. Depends on what stage you are in. So if you purely have your own in-house design, you're looking for OEM, ODM, we can find the suppliers to fit your needs. And or you need some support to design your product. Or even you have only idea and you're looking for suppliers to do a consultant or do the rest of the management or project for you. We can dig out what kind of a requirement or what kind of status you are, and to help you to try and find the one that fits your needs. And also under Triple, if your technology is require kind of like value added, we can link you with those non-profit organization. Probably there's a specific technology that can add the value on your product, and link with the university resources if there's something relevant. So what we're trying to build is the win-win ecosystem. Staff have a lot of trends and direction and demands, and we leverage our the Taiwan advantage, who has been doing OEM ODM for past 30 years. We help them to start to commercialize their product. So become kind of like an ecosystem to for this startup innovation. So why Taiwan? There's three key messages I want to deliver. Triple is a matchmaking platform, and we have a strong industry cluster and startup ecosystem, and we have been the key leader in electronic supply chain. And also Taiwan now has the big national project called Asia Silicon Valley Development Plan, and which support a lot of try to build like an ecosystem for startup and friendly, and have the IoT drive or trends to be implemented in Taiwan. And I also want to share with you some of the resources for startup. There's two major projects under Ministry of Science and Technology, which is executed by E3, which is us. And there's outbound resources. You probably see TIEC represent Taiwan Innovation Entrepreneurship Centers. This project is basically subsidized Taiwan startup to Silicon Valley. So go to check TIECTW.com, or there's some brochures on the reception area that you can check out, or come to us if you need some more detail. And we have another project coming very soon. Probably will be officially announced in our next event in April, which is the inbound resources for startup, which support the overseas startup to soft landing in Taiwan. Yeah, for 1 month. So you got the tickets, accommodations, and the co-working space, and all those coaching resources together with Taiwan accelerators. So that's something I actually pre-announced here, and it will be official next month, beginning of next month. So why Triple? Each project, if you come to our platform, we will assign a specific PN, dedicated PN to you. And our main job is to help you to find the right suppliers for your projects. Because all our PN has very experience in the industry. And if your project needs specific supplier, we will explore those because they got network and those relationship. And beside that, we will add value to link you with those nonprofit R&D centers. And there's some chance for marketing exposures that we will invite you if that's relevant. And also resource sharing, like a lot of like a chip or key component, probably not easy for staff to get, and we can leverage our members to get that support for you. And sometimes like two different staff, probably they do similar things, and there's chance to cooperate to each other. So there's something that we can support under triple pool, this platform. And there's some chance of sales channel and bundle chance. We will try to link up with different parties. Like some of the member has to transfer from OEM to some channels in different regions. That's something that we can refer those resources to you. And those funding resources or business connection or those startup related resources, we can do the referral for you. That's something we want to bring startup the value or total solution to this team. So that's the most common question I will be asked, whether this service is charged or something. So far not yet, because this is a government initiative. Government will now reserve the budget. So please come to us and try to leverage these resources. But if you come to talk to a supplier, the commercial terms will be deal between you and suppliers. That's something I want to highlight. Okay, there's some snapshots. Currently, we have more than 40% of international cases coming to Taiwan to work with suppliers. And each year, we have more than 100 projects. And so far, cumulatively, there's 60 project has been matched successfully. And I will run quickly about the case. This is the technology to control digital world. This actually work with mobile VR. The teams work on this apparel with the sensors. So the real, you can feel the real digital world. That's the alumni from the Highway 1. And there's panoramic videos funded in Kickstarters. And there's French teams doing a relaxation headsets. That's the portable heart disease monitoring. We help them to find the supplier for the chip. And there's dart machine to transfer the traditional dart machine to adding the digital scoring system inside that. And that's the most important case I want to share with you. That's the space case, the most advanced smart suitcase. It got BioLock, self-scale, global tracking of your luggage, and power bank, and BT for speakers, and anti-thief function, and app, and the cloud. And it's got in Kickstarter, it got 920,000 pledged. And the Taiwan supplier helped them to do the system integration all the way from the marketing concept to the final product. So I want to share with you a little bit about this story. That's, as I mentioned in the previous slide, it's got very successful in the Kickstarters. And that's also our first overseas case in Triple when we just started. And the founders is doing the traditional suitcase, but they want to add like IoT or digital function into their suitcase. But when they come, when our PM find this project, approach them, they have only marketing features and they have nothing else. So they are actually looking for a supplier to do the actual work. So they come to us, they buy the ticket and visit Taiwan. Our PM help them to manage the meetings and talk to different parties. And then he thinks like, okay, I want to go to Shenzhen to explore the opportunities and whether to do the comparisons. And then he spent another week in Shenzhen and talked to different suppliers. And in Triple, we think, probably he will stay in Shenzhen and we'll come back to Taiwan. And after censorship, they call us and contact us saying, okay, can I talk to the supplier to you? Because I realized that I feel more like IP protected in Taiwan more than the Shenzhen. So eventually he stayed in Shenzhen and talked to, I have decided to work with our supplier who is also the speaker today. So as I mentioned, they started with only marketing features and nothing else. They only have like a PPT slide. I want this kind of features. And the SlingX from Davey from SlingX helped them to try to lock down the technical spec all the way until this luggage smart suitcase has been shipped recently, right? Yeah. So welcome to check out this product after the course today. So I want to introduce the most important part for today, which is Davey. He will be talking about the 8 aspects of thinking in designing a product. And let me highlight, probably the information will be more like technical and hard for today. So feel free if you have any question or you want to have some of the real cases, then we can stop Davey and probably he can share his experience about the startup project. All right. So let's give Davey a warm welcome.
Okay, thank you. Yeah. Okay. All right. Good afternoon, everybody. Thanks for sharing your time to join this session. And I just afraid that maybe I will forget something, so I prepared okay, right here. Yeah. Okay. On the thanks for the Alan's introducing about the smart showcase, the space case 1, and I remember on the September 2015, one day, okay, the Triple has just bring my customer to my office, and my customer just showed me the one video on the YouTube, and he made the one that he's put on the Kickstarter, okay. And he told me that he has raised more than $2 million US at the Kickstarter and the Indiegogo just for this case. And he wants me to do it out. So that, okay, we accept this job and build it. And then from concept and test and to manufacture. And finally, we have the shipping more than 1,000 units this year. And we'll have the more PO next. Yeah. Okay. And I'm David Peng. Okay. I'm just on behalf of the SlingX and SlingX. It is also a startup that focuses on helping the startup and the entrepreneurs in designing products and from concept to design and the test and even for manufacture. Yeah. And today, in the past, in my personal career, okay, I have more than 25 years in this electrical field and more than 15 years stay at the EMS company. And in the past, okay, I also had lead 16 R&D people, and also act as Sony and Intel strategy product PM. Okay, so that and I also handle service at the Lion and the JBL circuit. So according to past experience and I had joined some lecture and some activity within these 2 years. So I find that most of the lecture has addressed. Oh, sorry. Yeah. Yeah. Okay. Most of the lecture just address on telling a startup or entrepreneurs about. Wait a moment. About how about just your design process, but they rare to tell you how to do the design. So I always thinking something that how to help those startups when they design to have the good design and the good quality in the design process. But the most important is not the design process, but it's some aspect that you must take in consideration more in advance. Yeah. Okay, today's session I will base on two assumptions. Okay. One assumption is I just regard that all of you have approved have do your homework and approve your concept, and even you have a good PoC product on hand already. And the second assumption is we will use the outside-in design process. For the design process, basically we will have the two kinds of the design process. One is outside-in, and the other is inside-out. And what's the difference? Outside-in, that means, okay, we will have the ID first. And then because ID will, for most of the buyer, the ID will impact whether they will buy it or not. So the ID will take some important roles in your design process, in your design. So this is from ID, and then we have the mechanical, and I have the PCB board dimension. That is we design from ID and go to the EE. Yeah. But inside out, that is another way, just on the contrary. That is we have the PCB board first. We test it and do some PoC concept. And then we based on this and to generate our looking. And most of the makers take this because they like to use, for example, the Raspberry Pi or Arduino to test their concept. And then based on this, those modules, they will try to make a one ID and just fit for this board. But today, for normal design process, we will use outside-in design process. Okay, and this, oh, sorry. Yeah. I believe most of you have seen this process already, right? Already, this is a PoM process. And I think most of you is a very, some of you should be very familiar with this process. Because everybody in such a session, they will tell you, yes, when you design a product, you must obey this process. But okay, this is only a process. They didn't tell you how to do that, right? You can follow, okay, EVT, PoC, EVT, DVT, PVT. Yeah, it's just a lump, but it means nothing. It just means some action. But how to do this action? Yeah. Oh, sorry. Okay, this is some action that we have to take from PoC to EVT. And this is some action that we go to DVT and the PVT. But right here, I just want to point out that the most important right here, okay, is I want to ask one question to all of you. What's your main purpose when you design a product? Can someone tell me? Yeah, okay, maybe this one. And Hannah, can you tell me what's your purpose when you design a product? Money? Good. Yeah, very close. Yeah, very close. I think, okay, the most, my answer is just sell this product to market, right? To get money, right? Yeah, okay. But how? What word? You want to save the word? Okay. But you don't have the, you don't print the S. No, you don't print S on right here. Okay? Superwoman now. Okay? Yeah, so what I want to emphasize is, okay, from this chart, okay, there is some items that will impact on the last mile, that means the selling to the market. I think, okay, within this, okay, what do you think, which item that you think that will impact or have some relation for you to selling your product to the market? Even you have the design is very good. Which item? Can someone tell me? No? I think the most important item is certification. Yeah, because if you don't pass the certification, you cannot sell on the market for US. If you don't get the certification, get the FCC ID, it is impossible for you to import and even to sell on the market. If you don't pass the Taiwan, the BSMI or NCC, you don't get the license, you are unable to sell on the market. So even you do your design very well, okay, then it is impossible for you to sell on the market to get the money, right? And besides certification, what else that I think, that you think? Okay, for me, okay, I will tell you, it is a reliability. Because why? Later I will tell you one story, okay? Because why? Because if you don't get your product past the reliability, have the good quality, stable quality, then you will have you will take a very huge risk, just facing some penalty from some company or from your customer, or maybe you will facing some RMA issue after your shipping. So these two items, I think it is the most important for your the whole design cycle. So that I want to trace back from these two items, or even three items, from some items from the manufacturer side and on the market, and looking back how you design your product, and what's the major issue for your when you're designing a product. Okay. Can someone guess what this photo means? This is a story, a true story that happened at Foxconn. Similar, okay. At the 2008, Foxconn has been penalized by Lenovo about 240 million. That is because only one capacitor. The issue is only one capacitor. At that year, okay, they shipped the motherboard around 2 million pieces to Lenovo. But after half a year, okay, Lenovo just tell them you have the RMA issue. They want to return all of these 2 million and ask for some penalty to Foxconn, just because one capacitor, that he lost his function when it is after a long time high value working. He just lost his the function, so that the power of this the motherboard is very unstable. Yeah. So that Foxconn just to be fined, okay, 240 million at that year. And almost one senior vice manager, okay, vice general manager almost quit just for this issue. And this means, okay, what, because this is a concern with, okay, before we shipping, and we will do some reliability test, especially we will do some thermal test and component life test. But at this, for this issue, for this event, at that time, Foxconn did not test this component very well. And so that he got this issue after half a year. Yeah. Okay, let's go to this main topic. Oh, sorry. Okay, so that this is what I want to talk, discuss with you from the S aspect in the design process. Okay, when you're designing a product, I think this basically okay. Each item of this aspect can be separated just as a major topic to discuss with you for, I think maybe for one day. That is okay. So that today I just want to have a general scope to all of you, what we think in design a product, what is the most and how to think about this. Okay. Now from here, okay. Sorry. 总是没有。Sorry. Okay, so from here, okay, these three items, just from the view of the manufacturer, and we want to talk about this to see some design concept and at some point, and then trace back to this how we to design a product. Yeah. Okay, this is what I think the most a very important step when you design a product. Okay, it is a system block diagram. In the first, okay, when you design a product, you must generate a system block diagram. Why? Because wait a moment, I forget. Yeah, because let me see. Yeah, okay. Because when you see this block diagram, what can you read from this diagram? I think okay. You can read at least some items listed right here. You can list the function of each block, right? So that you can see right. You can see right here. Here is the function of each block, and you can also see the interface, how those blocks connect, and how those blocks work with each other. And you can see some from here. You can also see some how the power goes. So you can see the voltage, because we will use some different color to show some different working voltage on this system block. So it was very clear for you to talk with your guys and your engineering guys. And even you can use this block diagram to discuss with your mechanical guys. Because when you design a system, the mechanical guys need to know, okay, where to put those I/O interface. Right. So we can use this and talk with them and how to place them and to generate a general scope of a device. And also, okay, you can use this block diagram to list your power budget. When we design a product, the power budget is very important to us because we need to provide a sufficient power to a whole system. Otherwise, you have to do some we call it engineering change. When you find out the product is not enough for your system. Yeah, especially okay. This case is especially more easy to find in some the communication system, especially for the for example 3G system, because for a 3G system the power consumption is just depending how clear the signal it is. Yeah. So if the signal is not so clear, it will use more power to communication with the base station. So at that time, it will consume more power. But if your power budget is not enough, you will find, okay, the system maybe will be shut down or even you cannot link. Yeah. And the other is when you want to estimate your general, have the general understanding about your cost. I think this product also can help you some. Because for my habit, okay, I will also list some component cost on this product, on this product diagram. So that you can calculate, when someone wants to ask you how much is the cost of your system, you can have the general in calculation. Yeah. This is one system product diagram. So that you can see this is a function. Then all this the function and the chip length and the function, and also we have the list some the power consumption right here, and we translate into this table, so you can have very clear to know how your power budget. Yeah, and even you can to check for example, right here they have the some interface, so you can use this to calculate whether your system can support so much interface. Yeah. This is another power budget format. This is more clear. And use this, you even can calculate the efficiency of your power system. Yeah, because the power system, the efficiency will dominate your the product, the thermal performance. And for thermal, we will talk about it later. Okay, right here, yeah. This is the second chapter, usage environment. Okay, right here, basically, this is, we are talking about is reliability. Because a product, the environment of the product that you use, okay, the environment will design what kind of the tester that you need when you're designing a product. For example, okay, just imagine that you live at somewhere near the seashore. Okay, for example, maybe Dubai. Okay, you live there and maybe you're running there. Okay, so and have a mobile phone, just talking or some of the other device. So I just want to know. Okay, just want to ask you, what kind of the tester you think those devices should be tested? What kind of the test? They live at the mobile. It is a very hard and a very and close to the sea. Yeah, so maybe you need to have some tests about the temperature and the humidity, right? Yeah, and even because it's just near the seashore, so even you will need to do some, we call it a spready test. Just to test whether the device will be can endure such an environment with in such a salty environment. Yeah. And this is environment test. This copy, this spec comes from the S company, Japan S company. And wait a moment. Most of us, when we do such an environment test, you can see that I have to say that for environment test, we have a lot of kinds of spec. This is the most general and the most softy spec for temperature test. So you can see, okay, they have the two temperature. One is 65 degree and the other is 40 degree. And we will have the run it for let me see how many times, 126 cycles. Yeah, to see it can endure such an environment, such a test. And after this, the DUT must be should be able to work. But in another kind of the test, we call it thermal shock. The thermal shock is more severe than this test. For example, in my past, okay, Sony, also for Sony has one thermal shock test. The spec is it range the temperature between the minus 20 degree to 125 degree, and it will go up from minus 20 to 125 degree within 1 minute, and then stay at 125 for 90 minutes, and then goes down to minus 20 within 1 minute, and stay at the 90 minutes. And then this cycle will repeat 1,000 times, because it just simulate, okay, the aging. The aging test of just simulate for 10 years aging. Yeah. If it can pass this test, okay, that means this product will be much more perfect. Yeah, and also that's why Sony didn't earn a lot of money. Yeah. Because Sony's product never fails, so it is very hard for you to replace it, to buy a new one. Okay, right here. Okay, I also want to have some short introduction about some product category depends on the temperature. One is the commercial grade, and the other is the industry grade, and the car grade, and the military grade. Yeah, this is the 4 kinds of product category. Yeah. And next, this is what we call a source ready test. Yeah, this is just as it is a steric corrosion that produce a corrosion attack to coating samples to see whether the surface will be impacted or corrupted by soap. Yeah. And the next is waterproof and dustproof. I think this spec is some of you will be very familiar with this, because most of the mobile phone right now just emphasize my mobile phone is waterproof, or even it can immerse or use underwater. So they must pass this test. And for this test, we call it the IP rating. So, for example, okay, for some the Sony mobile phone, it is for the IP67. IP67, that is okay. For the first number, it is for the dustproof, and then the second number, it is for the waterproof. Yeah, IP67, that means okay, it won't be dust can get in and can put underwater 30 centimeters just at least for 1 hour. So we have to do a lot of such a test. Yeah. So test back when you design a product, your system architecture should know okay what kind of environment this product should be sold, and then design the environment and design what kind of the reliability and what kind of the test that this product should take. Okay, after you get all of those information, and then we can pass to the designer, and then know how to design your product. Otherwise, if you don't have such information, you will redesign your product many times, and you will waste your time, waste your money, and even you will lose your customer. Yeah, this is another test for drop test and the vibration test. Okay, sometimes a drop test, I think a lot of should know because we just want to test whether the mechanical design is strong enough or not. Okay, so we will have this test for For some components that we will have the auto bonding drop from maybe 150 centimeter, or just depends on a different requirement. But in another way, we also will have the some yeah. And for okay, for vibration test, okay, it has two kinds of purpose. One is to test your package is okay for shipping or something else, and the other, sometimes we will use that to test whether our component is soldering well or not, especially for some deep components. Yeah. Okay, this is a whole, and we call it a whole test. This test is something different from the previous, because the previous test they all do they all done separately, but this is a common test, combination test. The purpose of a whole test is just want to speed your test time. Just for example, if for the cycle for temperatures cycling the test, sometimes it will take you almost 1 month. But when we design a product, as you know, okay, the timing is more and more shorter than before. So we are unable to endure, okay, to have a test that spent on 1 month. We hope we can do it within just a few days, and even at least at most only 1 week. So we have this whole test to speed up your test, and it combines vibration and high low temperature and even some on-off cycling together, so that you can do a lot of tests at one time. Yeah, okay. This is another topic, okay, another chapter about, we talk about certification. I think the certification is terminology is a very, to everybody is a abstract terminology, right? Because I think most of you must heard about FCC, UL, CE, and even some, for example, some Wi-Fi test or something else. But anybody exactly know what FCC does, or what UL does, what FCC tests, or even what CE stands for? Yeah, I think very rare people can clear to say that. Even some engineer, they only have some concept, but they don't have the very clear picture about it. So today I just want to have a general scope to you about this certification. Yeah. Yeah, for FCC it is and UL it is for the USA spec. For FCC it is about the EMI and EMC tester. This is I think this one can have the more clear illustrate about the difference. Okay, C it is Europe the test standard, and okay for C okay it can include the EMC and the safety, these two parts. But for USA okay. Let have the different the entity to in charge of these two parts. And for FCC, it's just in charge of the test of the EMC, and for UL, it's just in charge of the safety. And this is EMI. That we call EMI. Basically, okay, it is a radio frequency energy that will interface the other device. For example, any electrical device that if they have some frequency operating in their system, it must generate some radiation, a frequency radiation. So those frequencies will impact on the other device. So that the EMI is FCC EMI is just try to keep under their spec to not to prevent you to interface the other device. So on this chart, you can see there has two lines. The red line is the up limit, and the green line is the tolerance. Yeah. So once your radio frequency is above is over the red line, okay, this device will be fail, and you have to try to minimize the intensity of this radio, this frequency to pass the test. Yeah, this is some EMI, EMC. Yeah, this is we call it a 3-meter chamber and the 10-meter chamber, and here is the standard for different country for the EMI and EMC. Yeah. And for Taiwan, this is Taiwan BSMI, and this is for US and have the FCC PoC 50B and the 50C. It has two kind of different spec. And this is talking about safety. Basic, okay, this they have the 6 scope for safety. Yeah, the first scope is just for the electrical shock damage. What is the electrical shock damage? I'm not sure whether you have such experience that in the winter, when you open the door, maybe sometimes you will feel your finger is very, very pain. Yeah, it's very, very painful. That means it is shock. You are shocked by the static electrical. Yeah. So this is the electrical shock means okay. It will test and ensure that your device is can endure some shock from the nature or some from the some power, so that the device will not be damaged. And this is also for the energy. The other is for the energy damage. How can I know? Okay, this one is how should I say this? Have anyone seen the spark? Just two terminals and with high voltage and very close, and then it will generate spark. The spark will generate a high energy, and easy to have some fire, to cause some fire. Especially when we design some PCB board, we have some rules to prevent you generate such a spark or such a damage. And the other is okay. The third is fire. Yeah. So the fire is once we have the some path value or something else that maybe will cause fire. So we will have such a test to ensure this device won't cause any fire, and so that for some, especially for some material. So for some material, we will have the for UL. It has some request about your material, what kind of the material that you must obey. For example, for the PCB board, we have the 94V0, such a material that must be used just for prevent against the fire. Yeah. And also, it has some scope for the mechanical and the thermal damage. And this is some of the, sorry. Yeah, this is the safety, the sub-spec of the test standard for safety all over the world for different countries. We also have to notice one is for the IF test. The IF test means right here we have a lot of the different communication systems. For example, you have the for Wi-Fi, right? And for Bluetooth, and for 3G, and even for example, DB. Okay, this all belongs to different communication spec. For different communication spec, it has a different the test, the IF test spec in lab. So that this test is we will test based on your product spec, and then the test category will measure at some frequency deviation and the power and the timing. And what is the frequency deviation? That is when how do I say? For example, one frequency it has some central frequency, and if you it is not at the right frequency, okay, it just go right or go okay. It has some tolerance. If you over this tolerance, it is fail. Yeah, and even okay for the power, we have some power that for example for Bluetooth it is 0 dB. It is a very weak the power the transmission power. But if you are over the limit, maybe you will impact the other device. So they have some limitation on that. And this is all must be listed in the designer spec, so that the designer know how to design your system. Yeah, this is some RF test. Yeah. And then this is a SAR test. The SAR is to test the radio that absorbed by your human body, especially just for some, it is must need for the communication system. So right here you can see here is some the test location for some device. For mobile phone, some for FCC it justify it must test for the head and the body, the amount for head to absorb and the body absorb. So it has some device. This is earphone put on here and to test how this to absorb. Yeah. Okay. Next is another important topic for you design your product, and this we will also take this into our consideration in advance. This is about manufacture. When you design a system, okay, you must know how to manufacture your product. If you cannot put this into your consideration as early as possible, maybe when you finish, after you test your boards, all the function of your boards well, you will find one thing that it is very hard to produce at a production line. And then you must do some change so that for the production line, it can save time and save the process and smooth for them to produce. But yeah, so this is very important for you to take into your consideration. For example, and the purpose of this is including for two items. One is to guarantee your product quality, and the other is just less your manufacturing cost. And for these items, okay, basically we will have including 3 items. One is a SOP. We call it a manufacturer test plan. And the other is the, we call it the test pointer and the test tooling design. And later we will have some example and show to you. And the third item is a manufacturer test program. And for the SOP, hello? Can someone just show this PDF file? 没有，这不能点，他们会秀。看一下哦，这边好像不能点，不行。对，要跳出去才能点。让我来，让我来，没有。对。OK， 可以。下面。OK， 我来。OK， 有吗？没有。Okay. This is a manufacturer SOP. And right here, okay, and the most important thing is this one. For this chapter, okay, you can see we will have some design about the test station. We call it the test station. And for this is a test station, this is a test station. And this is a test station. This is also a test station. Each test station has a different test item and a different functions. And so that you must take this into your consideration when you design your product. How to test in manufacture. Yeah. And also with this SOP, you can also to calculate how to arrange your production line, your test station. For example, if the test station 1, it needs around 60 seconds to complete the test function of the test station 1. And for test station 2, it needs 30 seconds. That means, okay, you need to double the test station 1 to meet the throughput of test station 2. Otherwise, the test station 2 will be the bottleneck for your mass production, and all the employee on the production line of test station 1 will be wait for the test station 2. Your test station 2 will be wait for the test station 1. It's just a waste of time, waste of your money. Yeah. So this must be taken into consideration. Okay. And next, okay, this is some test point and test tooling. When you just design your PCB board, just as mentioned, once you have the tag in what kind of the function that you need to test, you will add some the test point on your test at your PCB board in advance. And then this PCB board, we will have another test tooling. Oh, sorry. We will have another test tooling, this one. Okay, so we can put this board on this tooling, and we have the test pin that contact with this test point, so that you can test the PCB board very quickly. Just save your time. Yeah. And the third is, we call it the manufacturer test program. Manufacturer test program is quite different to the program that we call it the shipping image code. Basically, okay, let me say in this way, okay. The manufacturer test program, it is a special design, just of a special target at your test procedure. Yeah, for just for the example that I just showed on the SOP. Yeah, for example, if test one that needs to test, for example, okay, the power or something else, or even Bluetooth, or even the other function. So the program only will all focus on those functions, and it will automatically test those functions directly, and it will tell you pass or fail very quickly. Yeah, so it can save your time. And maybe you will ask one thing, and once my system just loading such a manufacturer test program, yeah, because we will load this program into our system. But how about after your test? How about the image program? Where it comes? Yeah, yeah. Okay, we will have the two ways to for this manufacture for this issue. One is okay. We will generate one program that after test, it will auto erase the original manufacturer test program and generate the image code you plan to shipping. And the other is we will use another tool to erase the manufacturer test code and the reprogramming again. It just depends on your design and your cost, because the first one, it needs a larger flash, and so your BOM cost will be higher. And then the second two, it just depends on your BOM cost and the labor cost. Yeah. Okay. This is another chapter about, okay, this is take into the design in real. Okay, we will talk about the design for the manufacturer design. Yeah. 好像时间不够是，时间不够。Okay. Yeah, because the timing is so I will speak very quickly about this. Okay. For the mechanical design, we will have some. I think this we will take these 5 items into our consideration. Yeah, at first. Okay. One is for the 3D interference checking, and the other is a thermal consideration, and the third we will make some more gap. And also we will take into the antenna placement into if your system needs a wireless, we will also take this into our consideration when we are making a design mechanical, the design of housing. Okay, and also we will take into waterproof if the system needs. All right, and for the 3D interference checking. Okay, this is one of our product. It is just 什么香怎么翻译？香。Incense. Yeah, right. Yeah, incense. Yeah, this is electrical incense. Okay. You can see this one is a very how should I say it? The mechanical is very hard to design. So right here you can see the max outside diameter is only 16 millimeter, and the max the inner diameter is only 14. It is a very small one, but we need so that you can see right here. For this one, we need to place some battery. We need to place some LED, and we also need to put the microphone and the even speaker inside this. So we need to do such a 3D interference checking. Otherwise, I'm not sure whether after I have I have my mechanical housing coming out and my PCB coming out, whether they have a conflict in real dimension. Yeah. So we will do some simulation in computer and so that you can check right here. Sorry. This is the original size, and this is we just made it transparent in some parts, and then we cut right here, so you can see every more clear of the inside, and right here you can see it is very complicated. Yeah. So this is a must step for you to design your product. And the second that we need to take into consideration is the thermal. For most of the IoT device, I think the thermal is okay. But for some device that use more computing power, the system will have some thermal issue. Yeah. But for thermal, okay, why we need to solve the thermal? Because the thermal will lead to your whole system to be shut down or something else. Just because once the thermal goes high, okay, that means the whole system temperature will be rise up. Once the system temperature rise up, that it means the system power efficiency will goes down. When system power efficiency goes down, because this system it needs so much power, so the only way is it must use more current. When it uses more current, that means another thing that it generates more power. More thermal. And this loop this circle will lead to the whole system just shut down. So that we need to solve such a thermal issue. And also the thermal will cause your noise rise up. So that if the temperature goes up, you will find one thing is that your signal will be bad. Yeah, the SN ratio will goes high. Yeah. Oh, okay. Yeah, okay. This is the way we try to solve the thermal. One is the conduction, radiation, and the convection. And okay, this is the example of to solve the thermal. For such a sink, the heat sink, it is a combination of the convection and the radiation and the conduction. Yeah. Because we call this fins. These fins, whenever you increase the area of your fins, that means you will have more area to convection to have the air convection to bring out your thermal, and then you have the more area to have the radiation out of your thermal. Yeah. And then this is some simulation at the computer. Yeah. We also simulation the airflow. Okay, and this is the issue the mockup. For mockup, it is also another must step when you design a product. Because the mockup it can verify the interference of your solid body and verify your color plane and to have the real visual effect and the feeling whether it meets your requirement. Yeah. And also it can verify if any issue occurs in real operation. Because the mockup, what we need is a working mockup. So you can use that to test, have the real test whether it meets the real function. Yeah. And also here has some tips. If you want to do mockup, okay, because mockup is not so cheap. Yeah. So sometimes if you need the mockup more than two pieces, we will advise you to do some soft tooling, and then use the soft tooling to do the mockup. It will save a lot of the money for you. And the other two items, okay, maybe if anybody has interest, maybe you can ask me or, yeah, after this meeting. Yeah, after this session, okay. Yeah, this is some layout strategy. For layout, basically, we will emphasize, especially just for the power and ground. This will be, for most of experience, the R&D, this is the most important issue, especially for the ground. Because the ground, it will impact on your signal. Yeah, so if a good ground, that means your system will be at least will success. I think more than 60%. The other just another design issue. But if you have the good layout in ground, it will be very easy for you to pass some certification. Also, yeah. Now, because of time, so I will pass this just directly, okay? Yeah, and this is some self-issue in, okay, we will also take this into consideration. This just means how the gap of the your layout trace. Yeah, and yeah, to meet some safety, especially for some high voltage and high current. Yeah. And the other, and this one is for some items that some criteria for the placement. Okay. Next, we will talk about this status transition diagram. I think this diagram, I think it is not so popular to some guys. Yeah. And this is for the firmware. And I think within this, our today's session, this one is as important as the block diagram, as the system block diagram. Because why? Because this status transition diagram, it just tells you how the firmware goes. Yeah, how the firmware it works. And also it also includes some of your confidential algorithm inside. And use this status transition diagram. You can discuss with your app team, because right now a lot of IoT team they need need to match with app. So with this, you can go with talk with the app team, and also you can use this diagram to talk with your hardware guy, because most of the status transition diagram is related to the hardware. Yeah. So when you design a product, especially in the beginning of the firmware, this is a very important diagram for firmware. At least you must have some general scope to have this picture. Yeah, to have this diagram in advance. Yeah. And the next is about the app and cloud. Okay. And this talking about just tell you for app we have the user interface and the user experience. User experience just tell you how the system goes, and the user interface just tell you how you to use this device. So it is very important for you to have such a two items and have some list about, especially for your user experience, because a good user experience that can help you to design a good app. Yeah, this is talking about the device, the relationship between device and the server. Yeah. Okay. Yeah. This is about some different mobile app, the web station or something else. Yeah. Okay. I think the most important is this one, so that from here you can see that from when you design an app and cloud, yeah, you must know, okay, we will take a special notice at this item. That is this for the app itself, for the UI UXX and the cluster device. For example, you can transfer from something the app for your mobile to your iPad and even to your notebook, right? So this we have to consideration the performance at a different device, yeah, different size device. And this one is talking about the API, the backend development. And so that you can see right here, it is a user authentication. Also, right, this is about security, and this is about the data service and the reusable business logic. This is about the cloud computing. Yeah. Okay. All right. I think Okay, this is today because I think maybe the time is not enough for me, so I speed the rest two several items very, very quickly. But today I would also like to thank some of my partners, yeah, especially for Gary. Hey, Gary, where is Gary? No? Okay. And I also want to thank for the Simon, because Simon has just provided me some material and just review my slide about the certification and reliability. And also I want to thank for Angus. Yeah, Angus is right here, okay? And Angus is also our friend for new startup. Yeah. And his company is expert at app and the cloud server. Yeah. All right. Thanks. Yeah. This is my session today. Thanks for everybody.
So thank you, David. Let's start with Q&A. So before Q&A, after the presentation, who think Howard is hard? I personally think it's hard. So any questions to David, or I just met new friend. We have visitors doing user experience. We have members coming from Wistron, now serving the Howard staff. We have a partner doing the EMS service. So if you have any question, I think we can raise the question to everyone, and then they probably have answer to you. Anyone? Or any question from the slide? Technical or in non-technical? So if there's no questions, okay.
Thank you. So I'm curious to, get your thoughts a little bit on how you would guide potential customers. Like you were talking about with the suitcase here. Customers that are coming to you who don't have hardware. This level of technical knowledge. How do you sort of guide them through the path to ensure that you get a successful project?
Okay. We will do some homework in advance. Okay. Because okay, let me say this way. When the triple just informed me that he has such a showcase to me, right? At that time, okay, I do the block diagram first. Right. Yeah, so that I analyze the customer needs and build up the block diagram, and also have some simulation about what he wants and what the users wants for this smart showcase. Yeah. Yeah. So that and also especially okay. For the block diagram, just as mentioned, okay, we can calculate the cost, right? So I also do some homework at the cost. Okay, so I think this is the key to win this project.
Right. Thank you.
Yeah.
So what I understand is the block diagram is the first document to communicate with staff if they only have the concept, right? Yeah. Okay.
Maybe I also want to mention one thing is because maybe I speak so fast and so sorry. There is one story that I forget to mention is just based on your question. Okay, a lot of the from the past 1 year, a lot of the customer and some startups just come to find me and want to do some product. And I think the most important is they must to evaluate their finance at first, and then and then have to evaluate what they want to do, so that a lot of startups, I had modified a lot of the concept of the startup. And even I just reject some of the startups, just try to save money for them. Yeah. For example, okay, in the past year, okay, there is one team. They want to do some gaming watch, IoT gaming watch. And then you want to use the Qualcomm chip to do this chip. He told me he has more than 50 million. He has more than 15 million US dollar cash on hand. But after our survey, we find it needs to pass a certification more and for 3G certification, and it will cost him 12 million. So I told him, don't do this because you just waste your money. So that this means you have to calculate your just be careful, just evaluate your finance at first. Yeah. And also, some company also asked me another question is how to find out a good partner to design your product. Can you tell me how to find it? Based on your experience, or?
You mean in terms of finding a good hardware partner?
Or maybe, yeah, just finding a design company for you. If you have a concept, you want to make it into a product, but you don't have such a capability to design it, but you find someone to design it for you and manufacture for you. How do you find a good partner to design it for you?
I think that's a massive challenge for any startup. You know, I think that it's about finding somebody who ultimately will be able to, you know, as you were saying with the watch company, who can come to you and say, hey, this may not be a good path. You know, really someone who can tell you the honest truth, really. You know, rather than just wanting to get your business, really.
I can give you one very, very simple and a very easy way to decide whether this is a good partner or not. You just ask him whether you can pass the certification for the board you design. If a good designer, a good design company, he must be in charge of to pass the certification.
Right, exactly. So then, you know, coming back to the process earlier, then it really seems like, you know, the certification really is the number one challenge, right? Because you know, if you have a great product, but if it costs $12 million to get it certified, then is it worth investing that time and money, right?
Yeah, right. So I think this is the most easy way for those startups that maybe they are not so familiar with the hardware process, maybe they don't have such experience in designing product, but they need to find a good partner. I think this is the most easy way. Just find a company that and the final just sign in your contract, and he must in charge of the passing the certification for you.
Sure.
Yeah.
All right. So
any question?
very important to find a partners, huh?
With the Indiegogo campaign or the Kickstarter campaign for that suitcase, did they raise that $2 million before they'd spoken to you and found out how complex it was going to be to build?
Yeah.
So how did they set the price before they knew what was involved?
Basically, I really don't know what the price is sell up to right now, even right now.
Right.
Yeah. But finally the price in the market, I think, will be within $700 to $500. Yeah. $500. US dollars. 500 to 700. Yeah, within 500 to 700. Yeah, because it just has too many features. Yeah, too many features.
Bigger one is 500 to 700. The small one is not.
Yeah, this one, small one. This one.
That one is 500 to 700.
Yeah. let's carry. No. 那个印加 GoGo 那个不准，那个已经过去了。Yeah.
Okay, so
Yep.
so before they launch, I think before they come to David, they don't have really solid
Yeah, they only have
estimation of the cost.
just make some post video. Yeah.
But they must put a price on it because people have to give them money.
Yeah.
So they're selling it before they know what it's going to cost them, which seems like a risky strategy.
Yes.
That's why a lot of crowdfunding project has been failed because they underestimate the manufacturing cost. So they realize when they come to manufacturing and realize, the cost is far way too high than what they set up the market price. So that shows that if you involve those hardware partners in the early stage, they give you high feasibility on the the cost.
That you might never take the project on in the first place.
That's possible.
Well, I think it would come much more realistic, but yeah, sure, options, yeah, but yeah.
Okay.
All right. So, any more questions? Otherwise, I will hand the ending to Stephanie.
Anyone else have any questions? Last chance. All right.
Or we
okay.
can ask questions during the networking section, right?
Okay, thank you so much again to David.
Okay, thank you. Thank you.
I hope that you guys were all able to learn something from his presentation. Our next Hardware Massive event is happening on Friday, April 7th, so stay tuned. I know you guys must be very hungry and thirsty after the presentation, so we have craft beer on the side for you guys, and we are preparing very, very delicious Mexican food, so come get it.